We're going to learn how to solve quadratic equations by completing the square. Now, completing the square is not the first choice for solving, because if you can take the square root of both sides to solve an equation, then that would be the preferred method because that's pretty easy. So let's solve the first equation by taking the square root of both sides. If you're taking the square root of a square, you have to remember that there are two answers. Both positive square root of 7 and negative square root of 7 can be squared to get 7. So just let's remember the plus or minus. The next one looks more complicated, but that could also be solved just by taking the square root of both sides. The square root and the square cancel each other out. And don't forget the plus or minus 3. There are two answers when you're taking the square root of a square. And now look, we can just add 6 to both sides, and it's pretty straightforward to get the answer. So even though something looks a little bit complicated here, it is easier to solve using the square root of a square, and that's the whole point of completing the square. We're going to make things look like this so we can take the square root of both sides. One more caveat, always try factoring first, because that's easier than completing the square. If you can factor it, then it's easier. It's almost always easier than completing the square. So the goal of completing the square is to get things to look like perfect squares so that we can use this to solve the equation. And so we just need to recognize what perfect squares look like. So what I can do is I'm going to square these out, and we'll see if we can recognize a pattern. So if you FOIL this out, you'll notice a couple things that will help you recognize what a perfect square looks like. This is a perfect square, and it's a perfect square because it's x plus 9 quantity squared. And if you look at the parts of it, you can see that it does kind of look like a perfect square. This 81 is a perfect square. It's 9 times 9. And the 18 is 9 plus 9. The same thing happens over here. We have a perfect square, 121. And, oops, we have, that's supposed to be a 2, 22. And we have twice 11 in the spot where b is. Again, a, b, and c are the coefficients of this polynomial. We can use these patterns to help us recognize what is a perfect square and how to make it a perfect square. This 18 is the most important clue. That'll tell us that we must have started with x plus 9 squared. So this number 9 is 1/2 of 18. And then look at the 81. The 81 is 9 squared. So that's how we're going to make perfect squares. Before we go on, why is it called completing the square anyway? Well, if we think of the area model of these polynomials, let's look at the areas of different boxes. If this box is a 1 by 1 box, then it has an area of 1. If this box is 1, it's the same height as the first one. And if we don't know how long it is, we'll just call that x. Then the area of this shape is x. And likewise, if this is an x by x box, then the area is length times width, which is x squared. So if you use these shapes and try to figure out what we have here, we have an x squared term. So that is in the first box. There, that's our x squared term. We have 6 x's. 1, 2, 3, 4, 5, 6. We're going to organize these, and we have 4 1s. 1, 2, 3, 4. So the area of all the shaded parts is x squared plus 6x plus 4. And I think you know where I'm going with this is that if we add a few more boxes here, we actually have a square. We've completed this square by adding enough numbers to make this a square. And let's look at the dimensions of a square. This is x, and then here are, from here to here is x. And we have 1, 2, 3. So this is x plus 3 units long. and x plus 3 units wide. So if I find the area, length times width, the length times the width, we can see it as the area of this shape. So we completed the square to get a perfect square. So let's put this together and complete the square. By the way, I did change the problem here. The idea here is that we're trying to get this to look like some binomial squared is equal to some number. Because again, we're trying to, if we put it in this form, we just take the square root of both sides and everything's easy. So we're going to have to take x squared minus 6x and turn that into a perfect square. So what I'm going to do first of all is just get the 1 on the other side of the equation by subtracting 1 from both sides. Okay, so we can take this left side now. If we add the right number to it, it'll be a perfect square. So let's look at what number we need to add. If we noticed the pattern before, that this minus 6 was twice as big as the number which we started with in the parentheses. So we know that minus 3 should go in the parentheses. So again, this is, we take 1/2 of this number. So this left-hand side of the equation, if we do it right, is x minus 3 quantity squared. Okay, so let's do it right. And the way we need to finish this is this negative 3, if we square it, negative 3 squared, oops, that's supposed to be a 2, we get 9. So we just made, so x squared minus 6x plus 9 is the same thing as x minus 3 quantity squared. If we add 9 to one side, we need to add 9 to the other. And on the right-hand side, we can add those together and get 8. So now we do have something that's in a form that we can take the square root of both sides and solve. So let's do that. Take the square root of both sides, square root of this side, and the square root of that side. So we have x minus 3, the square and the square root cancel. Don't forget the plus or minus the square root of 8. Good. We can just add 3 to both sides. And if we simplify the square root, that's our answer. Let's do another one. Again, remember we're trying to write this in this form. A binomial squared is equal to some constant. So we've got to get a perfect square. The 3 is our clue, that this must have come from 1/2 of 3. So you can write 1.5 here. I think fractions are easier to do, so just 3 divided by 2 is half of 3, so 3/2. That's 1/2 of that. And then we square it. And so 3 times 3 is 9, 2 times 2 is 4. So we have to add 9/4 to both sides. So it looks like we have 16/4 here. And we're ready to take the square root of both sides and solve. Square root, square root. Don't forget the plus or minus. Hey, 16/4, that's a perfect square too. We can take that and simplify it. Plus or minus, that looks like 4, wait a minute, 4/2, that's just 2. So let me erase that, that's just 2. That's the square root of 4. Okay, so x plus 3/2 plus is equal to plus or minus 2. Subtract 1.5 from both sides, so it's negative 3/2 plus or minus 2. Now this one we can actually do it. Negative 3/2 plus 2 is equal to 1/2. Negative 3/2 minus 2, and let me get these in common denominators. So 2 is 4/2, so that's negative 7/2. These are the two answers. By the way, if you ever get neat answers like this from completing this square, it was probably easier to solve this problem using factoring, but we'll just kind of skip that for now. But what happens if you have a leading coefficient that's not 1? Let's start the process. And let's get 6 on the other side of the equation. But the first step is once again, I want something nice. here. That's my goal. So we're going to get that by dividing both sides of the equation by 4. We're just going to divide by the leading coefficient, and we'll get rid of that leading coefficient. So we have x squared minus x, and I'll simplify that 3/2. Okay, so from here on in, the process is the same process that you just that we did before. That this coefficient is really a -1, so you put a -1/2 there. Square 1/2 to get 1/4. Add it to both sides. We combine these to get 7/4. Then we can take the square root of both sides and solve. What happens if you run into a situation where you get a negative number here, so you have a negative inside the square root? Hope you remember that the square root of a negative number is an imaginary number. This is I times the square root of 7. So this is the answer. It's just a complex number. And finally, here are the steps for completing the square. Pause it if you need to take a look at this and copy them down.